Good morning, everybody. Thanks for being here. I'm excited to get to spend time with you to share a little bit about what we're doing at Native Seed Search, and I've got a lot of photos here so we can kind of get you, we can't be at the farm together today, but hopefully with the photos we can kind of get a glimpse at what we're doing and what the farm looks like. I'm going to start where Helena left off in terms of what does this look like for actually growing for the seed bank practically. What does that translate into as we put seeds in the ground and we harvest them and we try to make them available through these different outlets. For us, everything really starts with that regeneration sample, or often we just call it a regen. And as Helena said, a regeneration sample is a packet of seed that has enough seed in it to grow a genetically healthy population for that crop type. So depending on the crop, depending on the type, those could be as small as we're doing a regeneration grow out of wheat right now. Anybody have a little picture in your mind of how big that field might be? It is 1 tablespoon of wheat seed. So it's a garden about 3 feet wide by 15 feet long. And we're growing that regen. It's just enough to refresh that regeneration pack. We already have enough for distribution and increase and all these other things. So sometimes it's very small. Sometimes for something like corn, those packets might be a little bit larger, or a bigger seeded crop like these Espanola Valley fava beans. Ideally, what we like to have on hand, and I was just talking with Cheryl and Helena to confirm this, is we like to have 5 of those regeneration packs in the seed bank. And what that does is if we can set aside 5 of those regeneration packs, that gives us multiple opportunities to do a grow out. And maybe there's an early frost or a heat wave or pest issues or a pathogen. If something doesn't work, we've got at least 4 more opportunities to do that grow out again. And along the way, we might find out, we'll talk about that, we might find out this seed just doesn't do well in Tucson, and that's okay. The other folks, as we were talking about who's involved in that seed production, you all are involved in that seed production too. I know a lot of you work with Andrea as partner farmers, and you're growing seeds for your community, or maybe you're growing out some seed that came from the seed bank and sending some of it back. So there's also a team of partner farmers, I think most recently about 30 or 40 all over the Southwest, who are doing those grow outs in locations that we can't replicate in Tucson. And we really don't want to be doing that. Somebody asked in September, I think, like, are you, if you're growing out a seed from Hopi, are you digging up that field and adding more sand or trying to do something different? And we could do a lot of things, and we would never really replicate growing it out at Hopi. So our hope is really to just grow in partnership with each other and grow what makes sense to grow in Tucson, and then work with partners to grow seeds where they came from, and to keep those adaptations going on moving forward. So the other thing about what's in a regen packet is ideally we want each regen sample to really reflect and be a healthy representative of what the seed line as a whole could and should be. So we'll harvest a big harvest, and then those regeneration samples aren't just from a couple ears of corn or a couple of the plants. We want to get it all, winnow out what's not healthy, take away what's maybe diseased or stunted or small, and then make sure that each of those packets is a really good mix of the whole seed line, because we want to have the opportunity that any single one of those growing from that regeneration packet really represents the best of the best. And we'll talk about what does that even mean, best of the best, who's deciding that, what is that? But we want to represent really healthy, really strong genetics of that seed line. We also want to reflect the full diversity of that seed line. So we had a grow out a few years ago that was a black seeded sorghum head. And maybe about 15% of all the plants, we grew a couple hundred of them, about 15% was actually really red tinged. And we want to make sure we capture that in the regeneration packet, get the full diversity of how that's expressing in different ways into that, so we're not missing that opportunity down the line. The other thing, so I kind of think of it as there's different tanks that we have to fill as the seed bank. So the first tank that we're filling are those 5 regeneration samples, and then also setting aside whatever seed is needed to do those germination tests, because we want to have seed available to do those. That takes some seed, so we want to factor that in. The other tanks that we try to fill as an organization, the second one we call it an increase sample. And what that is that's enough seed to meet all of the free seed access programs. So Native American Seed Share Anyone of Indigenous heritage in the region can access, can you all remind me, is it 10 or 15 seed packets? 15. So 15 seed packets every year, no cost for those packets besides just getting them shipped out. So Native American Seed Share, the community seed grants, which is working with schools or food sovereignty programs or community gardens, tribal farms. There's bulk donations available. So if Salt River wants to grow out, Salt River pea on a larger scale, there's opportunities to say, hey, we want more than just 30 packets. How can we access some more seed for this project that we're doing? And then the Partner Farmer Program, which I know a number of you have accessed seed through that as well. So we want to set that aside and make sure that we fill up the regeneration packets. We're meeting what the seed bank needs, but we also have kind of this farmer or community scale set aside. So maybe that's a couple gallons of seed or a couple pounds of seed, so that we're not trying to kind of start over from that smaller quantity. We have enough that you can get to that scale of, I really want to feed my community or grow a field size quantity sooner. And then for us, the way that distribution works, and it's kind of changed over the years, we could talk about that maybe too over the course of this time that we have together, but distribution, the varieties that are available online or in the seed catalog is always changing. So for us, it would have to make sure that we're filling up the regen, that we're setting aside that seed for access through increase, and then if there's enough, if there's a really good quantity and we feel good about what we have, then it would be available for distribution as well. So some folks will say, where's that tomato that I purchased last year? What happened? Is it gone? No, it's not gone, but it's maybe out of this cycle because we're growing something else out. So that's why we really encourage people, like, we're not a seed company in the sense that we want to sell you the same thing over and over again. We would love to be irrelevant. We would love for that seed to be present in your community, and when you get that seed from us, you never need to get it from us again because you're growing it and you're sharing it and you don't need us anymore. That's ideal, and then we're just a backup, which we can talk about. So sometimes that happens. Jacob was saying, like, trying to build up seed for Salt River's growing of 15,000 acres. That may be a process of multiple years, of a 3 or 5 or 10 year process of going from a small amount of seed to doing really strategic grow outs to bulk up the seed that's needed to grow on a larger scale. Sometimes we can grow, we did a half-acre field just this last spring, and we were able to grow several thousand temporary plants of one variety. And so now that one can fill up all those tanks really quickly. But if we don't have that much seed available from the onset, we can do it in stages. Grow from a regeneration pack. Now next season we can plant more of a distribution size field, and from that, we can make seed available and also grow another one. So there's stages that we can ramp up that production as well.
Joel.
Yeah.
What do you call it, a tank?
Oh yeah, it's not a tank. I guess there's probably a better word for that, but just like different categories of seed. So the regeneration sample, that would be the smallest packets, fill up those 5 packets, and then that kind of fills the category of seed that's needed to regenerate the bank. And then maybe that 5-gallon bucket of seed that we're trying to set aside, that seed that's allocated only for those free seed access programs. So we want to fill that up next. And what I mean by that is just seeds don't go to distribution first. We don't want to make it available to the public and then we sell it and it's all gone and now it's not available to fill those other categories of need. Seeds go from the bottom up. So they fill the seed bank so they're safe and available there. Then they fill community access programs so that people can get access specifically if you're culturally connected to the seeds, and we want to make sure that's the primary way people can access seeds, that's always there. And then distribution, like all that other has to be available before a seed shows up in distribution. Does that answer that question?
Mostly.
Okay. Do you want to ask a follow-up or? Okay, cool. Okay, so I wanted to talk a little bit about, Helena mentioned those regeneration packets. How do we figure out how much seed goes into that, or how might you, if you want to do that as a part of your seed banking process? And for us, that really is the foundation of what we're starting from. The amount of seed that goes into a regeneration packet really depends on the population size of what is the crop that you're growing, and then what's your goal for growing. And for us, we're going to talk about isolation and keeping seed true to type. for some projects and some communities, that's just not a goal of like, we really don't care if this stays this certain type of corn or this certain type of tomato. We just want to have seed that's adapted and available and good for people to work with. If that's the case, crossing and tracking and doing all of those things may not be as necessary. We were working with a food sovereignty program that actually came down from some of the indigenous land up in Alaska, and they were like, we don't really care about true to type. We just want to grow adapted seed that works and that we can share and make available. So that might be part of the goal, and that might shape how you're growing in the field. The other thing I wanted to look at here is on the population size. You may not be able to see this really well, but we'll send this out as well as a resource. Seed Savers Exchange up in Iowa, they have a really helpful, their seed saving guide walks through and sets some of these numbers for different types of crops. So you'll see 3 different categories. The first is just viable seed. I want to save this tomato and I just want to have seed to plant next year. You may only need 1 or 3 or 5 plants to do that and have a viable seed. The second category is I want to maintain this variety, like I want to have something to share in my backyard and with neighbors and friends, but I'm not really worried about capturing the full genetic diversity. So that number might jump up a little bit. You'll see on a lot of them, it's 5 to 10 to 25, maybe 50 plants. And then for us at Native Seeds, we really want to capture the full breadth of the genetic stock and diversity of that seed line. So we're really starting with the number on the far right, which is genetic preservation. So when we're looking at, we want to save a, we'll look at a seed packet here on the next slide, but we want to set aside the genetic preservation for a fava bean. That fava bean genetic preservation is about 50 plants that we want to save seed from. So we want to make sure that our regen packet is not 50 seeds to start with, because there might be weak ones. We might have a gopher eat some. We definitely are going to have a gopher eat some. Some of them might have, chocolate spot or something else that would just make it weak, and we wouldn't want to save from that one. So at the bare minimum, we'll usually say whatever that genetic minimum is, let's multiply it by 1.5 times. So if it's 50, we want to start with bare minimum 75 plants. Ideally much more than that, and that gives us a little breathing room for something to happen, for us to select out a little bit and still hit that as our harvested seed from good, strong, healthy plants. That number should be at or above that genetic minimum for the population size. And then our book, I think everybody's going home with a copy of this, Saving Seeds in the Southwest. There's some varieties like Desert Chia or Devil's Claw or things where that's not going to show up in Seed Savers numbers, but you can find some of those references in that book, The Native Seeds, Saving Seeds in the Southwest. So here are a couple images of just what this looks like in the field. Something that's nice about working with seed, and a lot of you already know this, is it often doesn't take a whole lot of space to do seed saving for a variety. Because the seeds are so productive, we've looked at crop data from our yields. For larger seeded things like fava beans, we're often getting 50 times what we plant. And for sometimes things smaller seeded like Magdalena acelgas, we're getting 2,500 times the seed of what we planted. So there's a lot of opportunity on a small scale to produce enough seed to really share that out with people. So this one on the left is one we've got in the ground right now this winter. The Española fava beans, we looked at that. That's about 50 plants that we want to save to meet the genetic minimum for health and preservation of that seed line. What we've actually planted is about 225 plants. And that really gives us a lot of breathing room then to really, if there's any issues, we can select for those. If there's any crop damage, any frost damage, anything like that, we've got room to not really stress out. We're going to be well above that number. And then because of that too, that's just going to give us more distribution, so maybe we can fill up those categories faster. Fill up the regen, no problem, set it aside for increase and make it available for distribution in one grow out. The one on the right, this is a good opportunity to maybe talk about what Jacob talked about of as we grow, how are we maintaining the arid adaptations and the community needs that these seeds have. And Jacob mentioned that 60-day corn, when we grow on irrigation, it was maybe 3 or 4 years ago, we were growing an autumn June corn, and somebody came and looked at them, an autumn farmer, and he said, that corn is beautiful. I am not interested in it. And what he was trying to communicate is it was over irrigated. The corn was healthy and it was vibrant, it was beautiful, it was going to set really good seed. But as Jacob said, it was eating at the buffet table instead of a good portion size. And so we want to make sure that as we're growing, that we're meeting the same conditions that those seeds have been bred for so many hundreds and thousands of years. Because if those seeds become too dependent on irrigation and fertilizer and these other things, we might have a really beautiful crop, but then it doesn't work in a dry farming setting. And what have we actually accomplished? We have a lot of something to share, and that seed is not useful in that way. So this field we'll talk about a little bit more, but this was a Gila Pima 60-day corn. And so we grew it in a basin field. We spent 2 or 3 months with shovels and water levels trying to make this field leveled out in an area where it would capture rainfall from some of the buildings in the Ramada. And so because of that, we were able to really reduce the irrigation. So instead of having it on once a week or every 10 days even, we spread it out and we only irrigated it maybe 6 times over the course of the whole spring season, and then let the rainwater come in and do the rest of that work. And maybe Cheryl can remind me later, but we saw a really big decrease in the size of those seeds and that ear, but it finished faster because we were giving it less water, and we were getting a little bit closer to those dry farming conditions. So I think off the top of my head it was like 40% smaller, the ears and the seeds. But then that was a lot more reflective of maintaining that adaptation and making sure that was still present in those seeds so they could thrive in those other conditions. And we'll look at that a little bit more throughout the farm too. But that field's just a little bit bigger for that corn, because for our genetic minimum, often a regen packet of seed is about 300 seeds. We want to make sure we're getting a good ear from about 200 ears. So that's really different than the fava beans. And then something like a gourd or maybe a common bean, something that self-pollinates like the common bean or the tomatoes, that number would be much lower. So as we're thinking about laying out the farm, we're thinking about the size of those regeneration packets and the population size needed to fill that, so we can match that out well. This was another field on that half-acre plot that we were working on. And as we're growing for a regen, sometimes we're limited by how big that seed is and how much seed we have available. So we might we plant the whole regen, we plant it all, and then that's what we've got to work with over the course of the growing season. But whenever we have the opportunity, the larger we can make that grow out, the more breathing room we have in terms of error or something to happen, and also for selection to take place. So this was an area where we had been growing corn, and I'm going to talk about it in just a minute. Some of the issues that happened when we only started with 300 seeds. We had a really big heat wave. There was loss of pollen, there was loss of pollination. By having only 300, it made it really hard to get that 100 or that 200 that we wanted of really good, healthy ears. So somebody recommended, actually, Dr. Pratt, who's out at New Mexico State. We were talking to him and also a number of other people, Clayton Brascopy and others, of, oh, how do you do this for corn? Like, what does this look like for you? What's your number that you're trying to hit? Because everybody's got a different number and a different way they're going about. So he said, the corn geneticist, Dr. Pratt, their target was often 1,000 plants, and then that gives you a lot of room to kind of select and make sure you get anything off type or anything odd that's happening or low pollen. You've got a bigger population to work with. So we did that this last year with the Autumn 60-day, and with 1,000 plants we were able to surround them by a windbreak of sunflower mix to just create some humidity and create some wind shelter, and that worked out really well. We had them pollinating in a really hot time of the year, but we were able to get a really good seed harvest because of the shelter of those other plants and because we had such a larger population size to start with. So I put that down here. Again, we're often starting with how can we hit at least a time and a half as our bare minimum of whatever that number is we're shooting for. But whenever we can, we want to bump that number up so we've got more room to play with. And different people have different goals and different numbers, so I'm excited to hear from you all, like, what does this look like as you're saving seeds and crops? Like, how do you decide how much to plant or how many to work with? Some people have said ears from 100 mother plants, 200. Do you plant 1,000? Do you plant 1,000 with only the intention of selecting from the best 400? We've heard that. and then the rest of it is for eating or sharing, but that 400 is the stock seed that becomes the regen pack. So there's different ways to go about it, and I think a lot of that also comes back to how are you answering that question of what are the best? Are the best the most resilient? Are the best the biggest? Are they the ones that mature the fastest? Do they have the best flavor, the best color? They represent what that seed line has looked like in the past. So answering that, I think the default in our agricultural system is like the best is the biggest, the most calories, the fastest, those things, but that's not the answer for everybody. And I think what we're seeing a lot is the best is the most resilient, the ones that are able to be really efficient, the ones that can work in this climate or this soil or under this condition just on rainfall. So answering that question of what are you selecting for, that really shapes everything that you're doing after that in the field. Okay, so that kind of takes us into this idea of roguing or selection. And roguing is just you plant the plants, and then you're going through, are there any that you're not going to save from for a certain reason? And for some people, they might save for everything, or they want the whole diversity of the plant line. But in a certain thing, so like a cilantro maybe, if you save for everything, very, very quickly in just a couple of generations, that cilantro that was maybe slow to bolt and quick to produce a lot of leaves before it went to seed, that could be undone in just a few generations of not selecting for that. So it again comes back to what's your goal and what are you trying to do on your farm and your grow out. For us, a lot of people have asked, are you all developing new varieties? Are you doing plant breeding? No, that's not something that Native Seed Search does at all. Our goal is that we would select for true to type seed, which just means it looks like what it has looked like in the past, and that to the best of our ability, we would match the full diversity of the seed as it came into the seed bank as a seed donation or something that was handed off. I'm going to talk about in a couple more slides where that gets hard and where that gets tricky, but that's our goal. And so there was one example with an autumn June corn that was mostly white with a few blue seeds in it. And then there was a grower, so that was the seed line that we were working with. We were growing that one out, and that's what we were trying to select and match as we went forward. A different grower, not connected to Native Seeds on our staff or anything, was growing that same one out, and over the course of 10 years, decided I want to see more of those blue seeds. I want to see an autumn blue June corn. They worked with that for like 10 and 12 years and then brought that seed to the seed bank. That then became a new accession that was separate from the one that was white with the blue seeds. And for us, we're just trying to match what it was as it came in. So now that grow out will be grown and we'll continue to select for that, for the blue seeds all the way through. But really that work happens in community, it happens by you all, it happens by growers, and Native Seeds is the backup for maintaining that so that you have access, others have access to that seed stock. However you've changed it. Our goal is not to change it at all, though that does happen, and we'll talk about how to navigate that. A couple things in this photo. As we're selecting and as we're deciding we're not going to save from this plant, we're not going to save for that for this reason, some abnormalities are normal and they're just due to environmental conditions. So this was a Yoeme Vachi corn in this first picture that a partner Julian grew out in Southern California. That exposed ear tip, Helena did an amazing job creating this document that maybe we can even share down the road of abnormalities in corn seed growing. The exposed ear tip is just an environmental condition. It means there was a period of drought where the corn thought it was done adding, and then suddenly there was water, like a late rainfall or something, so that corn ear started growing and it burst past the husk. That doesn't mean anything's wrong with the seed, it just meant in that season something happened that shaped it in that way. But in some other things there might be an abnormality that's genetic and we don't want to pass on in the seed line, so we might decide I'm not selecting or growing from that plant because it's really vulnerable to disease, it's weak. It's not something that I want to show up in my seed line. The one on the right is a Mojave flower corn showing some tassel ear where the tassel is actually setting kernels where it shouldn't be. Some of that within reason you might see in some of the corns that you're working with, pretty normal in some heirloom indigenous corns, but within a range. If that was happening on all of the plants, they wouldn't be able to share their pollen very well. So there's just, again, it just depends on your situation and what you're growing and what you're selecting for. but having a sense of knowing, okay, this is passing through genetics, or this is just happening because of the environmental conditions of the field or where we grew it, that really helps shape the decision of selecting, and what am I keeping and trying to hold, and what am I, nope, I'm not gonna save that plant, or I'm just gonna eat that plant and I'm gonna share it with people, we'll consume it, but we won't save it as part of our seed line. And then what we'll see in this picture next is that selection is often reactive. So when we're selecting for something in our grow out, we're often correcting a cross or something that happened off type in an earlier grow out. So some traits don't express their cross until generations down the line. So having consistency in that process really helps us correct backwards and look forwards as seed growers. This, we almost never document to this degree, but this little Excel chart was of just an example of, okay, we don't need to rogue out all this seed and say, for us, the green ones were the only ones that did well. So we got like 15%, 30 out of 200 ears that really set good. So if we were saying this was supposed to be grown out in Tucson, those 30 would maybe be the only thing that we would keep. But because this is a coastal variety, it's actually, nope, the seed line's fine. We just can't grow it in Tucson, and that's okay. But that's where the partner farmers working with people in the right locations outside of the low desert region. It's just a reminder, that's why we do this, because these seeds have adapted and they're used to this location and they do well here, and that's different than the low desert corns that do well in Tucson. This is another example of just what roguing and selection looks like in the field. This was Texas Hill Country red okra, which isn't really rare. It's pretty well known and grown by different people all over. Does amazing in the heat. But because it's really well known, the traits of that okra are really well known. So it should have that really beautiful red stem. And as we were growing it, we were seeing actually about half of the plants were coming up. And it's kind of hard to tell, but the next one's down. First one has the red stem, looks on type, looks true to type. The second and the third plant in that variety were green stemmed. And they were healthy, they were growing well, they were putting fruit on, but they were not true to type. So that's where the records that Helena and Cheryl keep, that you all keep in your seed banking and your growing, were really helpful, because we could go back to the records and see, okay, it's been 18 years since this was grown out last. What was happening on the farm that year? Is it possible that a cross happened or something traded pollen with this okra? And so we did see the record show that other varieties of okra had been grown in pollination tents around the farm. So clearly one of those pollination tents had a hole, a pollinator found it, pollen was exchanged in some way between the green stem varieties of okra and this red stem variety of okra. So in terms of correcting in the field, what we ended up doing that year was we cut down all of the green okras, and it was awesome. We just ate them. They were great. But we didn't want them to be part of that population we were saving seed from moving forward. And the ones that were true to type, we had to go back through and take all of the fruit that had already set, take that down as well. Eat it. It was awesome. It was great. And all of the open flowers, remove them. But it was early enough in the season that the true to type ones could keep going. They could set new seed, they could be pollinated just amongst themselves, and we're able to do some correction in the field. But that's also where those notes become really important, because we need a note in that one, keep an eye on this one. Let's see if that correction helped, or if that needs to happen over the course of multiple growouts moving forward as well. So there are things that we can do, but it's really important that we grow out the seed again, that we keep an eye on it, and there's some consistency there. Something that I've been trying to think a lot about over the last 4.5, 5 years is just, as we're writing and taking notes, what would I want to know as a grower? What do I wish I knew about this seed as it's going into the ground? Because our accession sheets really help with that. But there are some years where maybe there's not notes from whoever grew that seed or where it was collected from about what it should look like or how it performed. And so we're trying to make sure, as we do crop data, Deshaun and I and the other members of the team, we're observing what would be really important to us. What did we wish we knew about? Was it really hungry? Did it need a lot of amendments? How did it handle the heat? How did it handle the cold? What time of year did we put it in the ground? How long did it take to go to seed? These things that are really helpful to know. So I'm just trying to think, man, if I'm not here, if Deshaun's not here, if 40 years down the road none of us are here, we're hobbling around the garden, but we don't remember because it was a long time ago. How can we get that on paper? How can we pass that on so somebody else could pick this up and say, oh wow, I've got some really good information about what this is, and if we're not around to ask, somebody wouldn't need to because they've got the information they need. And I'll just say it's time consuming, and it's hard to, it's easy to get behind, but we're just seeing the value of those notes is so important for maintaining the seeds and keeping them going. So we did, Helena and Andrea and a few others of us, we kind of did an overhaul on our crop data sheets maybe 2 or 3 years ago to try to capture more of that information. This is what it looks like. It's overkill. It's got like 40 cells in there, but we wanted to put down what's everything we might want to know about this plant when we grow it out in the field. And so what we did is there's about 40 questions. We bolded 8 of them. So we said if we don't get any other information except for these 8 fields, let's get that on every single one. And then outside of that, let's just get as much information as we can get. The more the better, but if we don't get it all, let's make sure we get these kind of baseline traits for everything that we do. And on some things may be more relevant than others. So maybe on that okra variety, it was setting great seed and fruit the whole season from May through November. So pollination at flowering, that may not be as relevant for that variety because it was, the temperature changed a lot, and maybe we'll just put in there what a range was. But for that corn, that Yoemivachi corn, the pollination at flowering, the temperature, that was really, really important, temperature at pollination, because it gave us an insight into, okay, that Yoemivachi corn in Tucson, it was like 98 to 110 degrees when it was setting seed and pollinating in June. And corn pollen often dies around 90, 95 degrees. So it makes sense that pollen was really poor and really low in terms of the set. And again, it wasn't anything wrong with the seed. It was where we were growing. It was the timing, it was the location. So that's just an example. We'll have that for every variety we grow, whether we grow 30 or we grow 70. Each of them has their own crop data sheet. That is ultimately where we want to get all the information. How much seed did we plant? How big was the planting space? How deep did we plant it? Some things like corn or garlic, we've really changed that over the last few years. Go much deeper, try to get the roots more developed. Spacing, we've kind of dialed in on different things, where we like it, what led to a positive result. So, and then all of us are we've got paper notebooks when we're out in the field. We're taking notes on sticky notes on our phones, whatever, and then ultimately just trying to have this be kind of the repository. Maybe 11 people are helping with that grow out. How can we get all of that information in one spot? And then something that I'm trying to do as often as I can is make this little summary paragraph at the bottom of those notes and just go back and just say, okay, we grew this Ramari espinaca. Here's what it was like. Here were some things we were concerned about. Here's what went well. We're really worried that there was a bunch of London rocket weeds, that maybe some of that was crossing. We didn't see any of that this year, but that'd be something to look for in the future. Is it starting to get bitter? Is it starting to get small? We try to keep as much isolation as we could, but here's what was happening. And those little paragraphs that's what I wish sometimes I had from some of the past. And sometimes we do, but winter's been a good time for us to catch up on that. And before we go on to the next grow out, make sure we get as much information down and kind of out of our brains. I've been amazed how often I think I'll remember stuff, and even just next year, they start to kind of blend together as we do different things. So getting them on the paper is really helpful. And then I also just wanted to talk about, this kind of goes back to who's deciding how these are shaped. If it's just me out there looking at them and thinking, oh, this seems good, that's bad news. But if there's a lot of people speaking into what that seed line has been in the past, what it could and needs to be in the future, then we have some criteria for that selection as we're going on. So this is the autumn, I know I'm going to say it wrong, but the Guribasho melon, the musk melon, and this was an example of some elders had spoken to us and said what we're saving seed from and what we're growing doesn't look quite right. Like it's too big, it's too smooth, it's not matching what we saw in the past. And so the way that we did this is with the way the seed bank works, Cheryl and Helena could go back to older varieties of seed closest to what was brought into the seed bank And so David Van Druff grew some up at Gila River, Jacob grew some up here at Salt River, we grew some at Native Seeds, Mission Garden, a partner in town, grew some. So we had 4 different seed lots growing a bunch of these melons. And we had a gathering at Mission Garden where we set out 50 different melons. And then there were elders that came that looked at those melons and said, that one's the right size, that one has a great smell and flavor and shape, and could kind of speak into resetting what we're selecting for. And then we can take those notes and say, okay, here's some pictures of this is what it really ought to look like, or here's a range of all of these are good, and get a sense of making sure we're maintaining that. And I would just say, as the seed bank, that is one of the things that is the hardest, is making sure we have opportunities like this where we can get feedback and people to speak into that. It's one of the coolest gatherings I've ever been a part of, but it's also, you know, we don't do that 1,800 times. It takes a lot of energy and effort to get people together in that way. And so it's where it becomes really important to have, you know, you all are on the phone with Cheryl and with Andrea, and we're having those conversations and trying to learn, what should we be selecting for? What's the need? How can we maintain that in this melon variety, in this onion, in this whatever it is, corn? So that was a really cool thing, and kind of because we're selecting for broad genetics, it gives a lot of opportunity for that seed line to drift this way or that way, as something that was maybe just on the edge and only showed up a few times in the seed line. If we don't know what we're selecting for, that becomes normal, and then that's what the next farmer sees as normal, and then a few generations down the road, we're selecting for something totally different. So that input is so important and helps shape the work of it, but it also kind of gets to what the seed bank can and can't be. So I just wanted to talk about that too, of as we Native Seeds and the seed bank, there's a lot of things that we are not and that we cannot be. So Native Seeds is not a genetic repository for down the road in the event of this crazy event. We can come back and look at this doomsday vault. It's not that. It's not a seed museum. It's not a research facility or a breeding program. And it really, we hope, is not the primary source or sink, like where seeds start or end their journey. We hope that the seed bank and the farm is just one small stop in a seed's journey, but that most of its journey is happening in community and with you all, with growers and on tables and being selected for in those ways. So, and then ultimately, I think with the seed line, we hope that what we can provide is not all those adaptations, because we just don't know what all the needs are for that seed to be in the future. But what we hope we can provide is a bunch of people could access a seed line that is healthy, that is genetically strong, and that has a lot of opportunity for future adaptations and selection. And then different growers can access that and take that in different directions to meet the needs of their location, of their growing, of what they want to do. And then I'm just going to finish with some pictures of the rainwater harvesting process. So this kind of gets to that idea of, we're growing on irrigation at Native Seeds, and it's because some years the rains don't come. And for us as a seed bank, I remember listening to actually Sterling present at the U of A Water Resources Conference before he was on staff, and talking about dry farming, and you know, you can get a really big harvest some years and then the rains don't come and there's no harvest. How do we balance that as a seed bank of, we need to be reliably producing these seeds. That's part of our responsibility to them, to maintain them and their care. So providing some irrigation is how we do that. But we also have to maintain what they need to be and what they should be. So over irrigating that is also a problem. So just the differences between some of the partner farmer locations growing those seeds in a traditional field up in the high desert versus us growing them down in the low desert. The Itoy onion we grew, and in some situations we realized, okay, this field's got too much water on it because the bulbs are getting really big and they're not drying down well, and they're not storing well because they got too big. How can we bring the water that we're supplying back down to where it should be so that they can be really resilient and they could operate and grow well with little to no water? So how can we push that, really stress the crops and give them only what they need, but also be aware of when those critical periods are of seed set, of pollination, of fertilization, and not stress them at those points that would produce crop failure, but really in the in-between growing stage. So for us growing in Tucson, we've been really trying to kind of develop a hybrid model of Ak-Chin farming, of floodwater farming. What we're growing, we're not going to do it in a traditional way. We really can't say this is the, the Tohono way that we're growing it, because some of the seeds are from all these different, we represent over 50 different indigenous communities and nations. But what we're trying to do is pair kind of the tools of modern drip irrigation and the resilience or the reliability of that flow with the wisdom and the knowledge of planting in basins, planting in ways that can capture and hold rainwater and sediment. So we're working to make sure our fields are like mini basins, that we are designing the rest of the farm to capture rainwater all throughout the farm, so that in the years where it's dry and no rain comes, we can still produce a healthy, viable seed crop. And the years where the very next year we got 8 inches of rain in July and we were flooded out, we have rainwater harvesting basins and berms and features that will spread that water and slow it and hold it. So we're trying to do that throughout the garden, and we're really modeling it off of some of you, Jacob had us up to Salt River about 4 years ago to show us around the gardens, show us the spiral basins that his team had grown in the community gardens there. We're just trying to build on that, not do anything new, but just learn from that and incorporate that in our growing. So this is one that we've got going on, a rainwater harvesting basin that we'll also plant teperies and devil's claw. We got to go with Joyce and with Clifford Pablo see the Tohono Community College grow outs in the fields and the layers of capturing the rainwater, and we're trying to incorporate that as we expand the farms in the fields, make sure that's an opportunity to have, maybe it's not traditional dry farming, but replicate that as best we can in the seed grow out fields here. And this is one example. So this field is a basin about 2 to 4 inches deep, collects rainwater from 3 different directions, and in monsoon we were really able to just shut off the water because the tomatoes, the corn, the lima beans, they were getting the rainwater, and we could let them really have that be the primary source of irrigation, supplemental irrigation as the secondary source, and not something we're banking on. So as we build out and design the farm, we're really trying to design it for maximizing rainwater capture, for being in the floodplain, as that's a great thing, that's where we want to be, and then to think about how can we maintain these adaptations in the seed going forward. Oh boy, I was trying to go fast. There's a lot still not to cover. I'm just going to go really quickly on this. As we lay out the farm, it all starts with the isolation distance and the size of that population. So that's really what's driving our crop rotation and where things are going to go at different points. We used to do this on paper, and that's still what I start with at the beginning of the season, but we've built this into systems where we're using the computer. There's some great GIS maps that allow you to kind of see on your farm layout how far apart are things, kind of as a pollinator flies, so I know how far apart those fields have to be for different crop types. Cilantro needs 800 feet of isolation distance, so we either need to grow it out in a tent, or we need to grow it far apart, or only do one variety to maintain true to type. And so that distance, the size of the population and the distance it needs, that's what really determines the layout of where things are on the field and the farm, as we're doing 40 plus varieties in a monsoon season. And that, it really works out nicely because it forces us to do a good crop rotation of changing the nutrient needs of those plants by forcing us to never grow them in the same spot twice. At least it'll be 2 years apart usually before we do corn in the same place, because that cilantro or that corn or that tepary bean has dropped a lot of seed as we've harvested it. So if we put it in the same spot, it's used those nutrients already, but that seed is also going to come up on its own. So we need to do it in a different place so we don't confuse last year's seed that's germinating on its own from this year's seed that we're planting. And it really honestly helps drive a really healthy layout for the whole farm. Excel, just Microsoft Excel or Google Sheets or something is a nice way to do this and keep it in the computer. So we used to do everything on paper, and we've kind of built out these maps of the farm in Excel so we can have blank copies that we print out at the beginning of the year and we'll draw in by hand on there. But because there's so many of us working out in the fields to keep us all on the same page of what's where, we've really started labeling and calling the different fields and even the different beds by different numbers and codes. So we can say, okay, go out to, field bed B9 and harvest this, this plant, or turn it over and be done with it. So having a little bit more documentation like that is also nice to look back in the past and see what was the layout 4 years ago. We can see that well. So. Okay, I went a little bit over, but I'm going to end there and just say, again, it takes a community. We are a small part in any of that seed growing, and I'm really grateful to get to be a part of that and to learn from these plants. But the grow out and the ongoing, those seeds came from communities. They came from individuals and from growers. That's where they're going back to. And we hope that native seeds can be, a safe resting place, a safe place for those seeds to be accessed and to be shared. But also ultimately that's not where the seeds reside, that their home is in gardens, is in fields, is on tables, is in people's homes and hands, and that we get to just be a part of that story. So thanks for your time. Thank you for the work that you're doing to share and shape those. And we're excited to just get to keep those conversations going this weekend, or not weekend, Monday, Tuesday. Yeah, thanks.